Last time, we revised the laws of reflection. The laws of reflections are applicable to all types of mirror, that is, plane as well as spherical mirrors. Here, we will look into two types of spherical mirrors. But before we see actual mirrors, let's see something which we use every day, that is, spoon. Here, the surface is curved inwards, and the other side, the surface is curved outwards. If you have seen your image in these surfaces, then the nature of the image is not the same. It is different in both these surfaces. So let's see an activity. In this video, you can see the doll, and the image of the doll is seen in the surface of the spoon. The surface used is curved inwards. So when the doll is very close to the surface of the spoon, you can see an enlarged and an erect image, right? Now, as I take the doll away from the surface, you can see what happens to the image. The image is inverted, right? As I take it close to the surface, you can see the image changes, and when it is very close, it is enlarged and erect, right? Here you can see the other side of the spoon, the surface which is curved outwards. You can see the doll and the image. The image is clear and not enlarged, right? Also, the image is erect. Now, as I take the doll away from the surface, you can see there is no difference in the image. The image does not get inverted. As I take it close, it is very clear, right? It does not get inverted. There is no change in the image, right? Isn't it fun? You can repeat this activity at home. So, a spherical mirror whose reflecting surface is curved inwards, that is, faces towards the center of the sphere, is called a concave mirror. A spherical mirror whose reflecting surface is curved outwards is called a convex mirror. So, this is a convex surface which is curved outwards, right? And this is a concave surface which is curved inwards, right? So how do we draw a concave surface, or how do we represent a concave surface on paper? So this is the concave surface which is reflecting. To show the other side which is shaded, you can use shaded region, right? Or else you can also draw it in this way and the part can be shaded, right? Similarly, a convex mirror is also shown in this way. So you can draw this. This is the reflecting part which is curved outwards, and that is a convex mirror. To show that it is a mirror, we have to shade the other side in this way. Otherwise, it will look only this way and you will not know whether it is a concave mirror or a convex mirror. Hence, drawing this is very important. All right. Okay. So let's see how an actual concave mirror looks. This is the concave part of the mirror. Some time back, we performed an activity with the spoon and the doll as an object. The surface used was curved inwards. Now, let us repeat the same activity with a concave mirror. Okay? In this video, you can see a concave mirror, a doll kept little far away from the mirror, and also you can see the inverted image of the doll, right? As the doll is taken closer to the mirror, you can see that the image changes, right? As you come very close to the mirror, the image becomes virtual, erect, and enlarged. The same way as we saw it with the spoon, right? Now, let us understand the terms used while using a concave or a convex mirror, right? If this is a concave mirror, then this central point of the mirror is called the pole of the mirror. It lies on the surface of the mirror. It is generally denoted by the letter P. Next, if I consider a concave mirror, it is a part of a sphere. What I mean by that is, say for example, if I consider this sphere, I can draw a circle on the surface of the sphere. Now if I cut this circular part, what I get is the concave surface. The reflecting surface of the spherical mirror forms a part of the sphere. This sphere has a center. This center point is called the center of curvature of the spherical mirror. It is represented by the capital letter C. The radius, right? This is the radius. The radius of the sphere of which the reflecting surface forms a part is called the radius of curvature of that mirror. PC here in this figure denotes radius of curvature, right? It is represented by the letter R. Okay. Now, the line passing through the pole and the center of curvature of a spherical mirror is called the principal axis. All right. The principal axis is always normal to the mirror at its pole. Now, let us enjoy an activity. In this activity, I have used a concave mirror, a screen, and the sun as the object. So, you have to take utmost care that you neither see the sun directly nor you see the reflected image of it inside the mirror. By mistake, the reflected rays of the sun from the mirror may damage your eyes. So, we have to be very careful. So, let us enjoy. You can see the mirror and the screen. Also, you see that the sun's rays are reflected on the screen, but they are not focused. And now they are focused. Since the sun is at a large distance, that is almost infinity, you can see that the image is formed at the focus. So the distance between this mirror and the screen is almost equal to the focal length of the concave mirror. So, did you enjoy this activity? I'm sure you understand better when you perform an activity, right? Let us understand reflection by a concave mirror with the help of a ray diagram. So let us consider a concave mirror. This is the principal axis, the pole of the mirror, this point and this point. Let us denote these points as F and C. Let's see what these points are. Of course, we have already seen what is C. C is the center of curvature, right? If two rays are incident on the mirror and the rays are parallel to the principal axis, after reflection, they pass through this point, which we have denoted as capital F, right? MC denotes the radius of curvature, and radius is always normal, that is perpendicular to the sphere at the given point, right? Hence, this MC is a normal to the concave mirror at this point. Hence, this is the angle of incidence, right? So let us denote it by theta, correct? If this is theta, angle of reflection, which is the angle of reflection? This is the angle of reflection, and that is also theta. Hence, what will be this angle MFP? It will be 2 theta, right? So, when the rays parallel to the principal axis are incident on a concave mirror, they converge or meet at a point after reflection. This point is called the principal focus of the concave mirror, and we represent it by F, right? The distance between the pole of the mirror and the principal focus is called the focal length of the mirror, and we denote it by small f. Now that you have understood how reflection takes place in a concave mirror, let us see an experiment. In this experiment, we are using a concave mirror and two laser beams to demonstrate. So, let's enjoy. Here in this video, you can see the two parallel beams, right, which are incident on the concave mirror and they converge. So, let's watch it. Isn't it beautiful? Okay, see how the beams get converged after reflection. I'm sure you must have enjoyed this demonstration.